Hello, everybody. I'm Brian. Today I'm going to be talking about polyacetic acid. Polyacetic acid is a bioplastic, meaning it is biodegradable and it is made from plants. From here on out, I'm going to be referring to polyacetic acid as PLA. So let's get started. First thing we're going to talk about is who invented PLA. The person who invented PLA is Wallace Carothers back in 1932. He was initially trying to create a low molecular weight product. The idea was if he heated lactic acid under a vacuum, he would have a very similar result to what he was looking for. The company he was currently working under was called DuPont. In about 22 years, he finally stabilized his product and he had a very solid, consistent method for producing it. And when he finally had all of this, DuPont patented his research and said, like, hey, we made a bioplastic. This is how it works. This is the applications of it. This is how it's made. The biggest problem with the method Wallace had come up with is it was incredibly cost ineffective, meaning the time and money and effort you'd spend to produce PLA would not at all be worth the return. So it pretty much died off. It didn't really get any traction right off the bat until about 30 years later in 1980s to 1990s, where two men by the name of Cargill and Dow, they went together and they formed a company called Cargill Dow Polymers LLC. What they had figured out how to do is mass produce PLA and sell it to the public and have a pretty consistent supply of, I believe it was corn, to their factory. And since this was right around the time when people were starting to realize how unhealthy plastics were for the environment, Cargill and Dow were able to seize this opportunity to bring PLA back to the mainstream and have it mass produced and sell everywhere. PLA is incredibly cool. This is because its manufacturing process only requires corn or sugarcane. It's entirely plant-based. And seeing how it's made entirely of plants, it would be biodegradable and not just sit in our ecosystem forever, like some other plastics that we currently have floating in the middle of the Atlantic. PLA can also have applications in the 3D printing space, since it's able to maintain its structure and it has a low melting point, so it's very easy to liquefy and produce a structure to it as well that it can maintain. The only disadvantage to PLA in 3D printing applications would be if it's exposed to a high amount of stress, it becomes very brittle and easy to break. PLA is also non-toxic to humans, so it can be found in everyday products such as bowls or leaf bags, and can even be found in some frozen food packaging. So pretty much on the inside of the bag, they would have a resin variant of PLA to help insulate and control your food. PLA also has excellent optical properties. This is because it's an amorphous structure, this which often leads to a transparent and glossy appearance. And since it tends to not form crystalline structures, it also leads to a higher clarity than some other materials. PLA can also be made into fibers with fabulous elasticity by using a melt spinning process. PLA also has the ability to be blended with other polymers to lead to unique or very high elasticity. And a popular variant of PLA is 1100D PLA. This variant of PLA comes in a resin form that is used to coat the inside of frozen food bags, as I had mentioned earlier, like drinking cups or even paper too. It's got a lot of applications. So, for my 3D for my 3D model, I made one in SolidWorks. This here is the base structure of PLA. As you can see, it has a carbon in the middle of it, double bonded to an oxygen, which is bonded to another oxygen, which is also bonded to a carbon. On this carbon, there is also a hydrogen. As you can see, I have it color-coded in case you are a little confused or a little lost. And this would be the base structure of it. And since it is a polymer, it would be a long chain of these exact molecules all linked together. So each one of those ends, where the blue is, and there's no molecule on the end, would either be another one of the oxygens or a carbon. And it would be that exact same repeated structure for a very long chain, which is what makes it a polymer. In summation, PLA is an awesome alternative to some plastics currently in use. It has multiple applications in industry, such as the optical industry, potentially fibers mixing with other polymers, or even in 3D printing. and it is a growing field. As we speak, in India, Thailand, and the United Arab Emirates, they're currently developing their own bioplastics factories where they're going to be producing PLA in order to try and make a swap for more green alternatives. This is a great field to get involved with. I highly recommend getting into it. It's amazing. Bioplastics are the future. Let's go green, baby. Here's a page of my references in case you were curious.